Well, Mary, it must be great to have Junior home on vacation. What did he do today?
Oh, he was restless. His artistic temperament, you know. So I took him to our garden club meeting.
That must have been jolly.
Oh, yes.
Where'd you get the idea the kid's artistic?
Well, if you were observant in the least, you'd have realized that he's very temperamental, artistically temperamental. It's the result of heredity.
Artistic? That kid's just ornery. Where do you get the idea that heredity has anything to do with it? You and I aren't what you'd call artistic.
Now, you speak for yourself and your family, John. Everyone in our family is. Why, my great-aunt Minnie was most clever. You should see the beautiful china she painted, all by hand.
What's that got to do with Junior?
Well, I'm just pointing out that we must treat him as we would a great artist. His heredity demands it.
Heredity? Oh, listen, Mary. Don't ever let Junior hear any statements like that. If you do, he'll be coming home someday from school reporting that he's quit to become a pirate, like your great-great-grandfather, Sir Lyceum Biles.
Probably it's just as well that we escaped at that point. I wonder if the lady is well enough versed in heredity to talk herself out of the corner she talked herself into. At any rate, we'll probably finish this excursion in science knowing a few more facts about the science of heredity than we do going in. Here, to present for our edification said facts on human heredity, is our science reporter, Emerson Markham.
Thank you, Bob Stone, and how do you do, everyone? Before we get started, we should mention that we are indebted to Dr. James A. Stouffer of the Department of Biology at Colgate University for the story of the recent developments in the study of human heredity.
Our thanks indeed to Dr. Stouffer. How long have scientists been interested in the science of heredity, Emerson?
Well, Bob, the science of heredity had its origin about 75 years ago when the Austrian monk Mendel published a paper describing the results of crosses made by him between different varieties of peas.
Peas? That seems a pretty far cry from heredity as I understand it. How about expanding and explaining?
Mendel crossed a yellow-seeded variety of peas with a green-seeded one, obtaining in the first generation plants that bore only yellow seeds. Crossing these yellow seeds, he obtained plants that produced both yellow and green seeds in a ratio of 6,022 to 2,001, or almost exactly 3 to 1.
And that discovery started things popping?
Well, not right then, Bob. His paper on this and other crosses lay in obscurity until 1900. Its discovery marked the beginning of a tremendous amount of research.
Did these later people come up with the same answers?
Yes, and not only were Mendel's results confirmed, but many other instances of 3 to 1 ratios were obtained. Likewise, exceptions were found, and the solution of these has led to the discovery of other types of inheritance.
How about us humans?
Well, in humans, inheritance has been found to follow the same patterns as in plants and animals. It has long been noted that certain traits pass down from generation to generation in a family, sometimes uninterruptedly, and sometimes skipping a generation. Most characteristics of this kind are now classified as dominant ones, and it has been found that when a person with such a trait marries a person without it, on the average, half of the offspring will show the trait.
What sort of thing do you mean?
Well, one kind of cataract of the eye is inherited in this way. Collected data from a good many pedigrees of this condition give us a ratio of 57 affected to 61 unaffected offspring. And then there's a disease in which the blood vessel walls are abnormally weak, resulting in frequent nosebleeds or bleeding in other parts of the body, which is also dominant in inheritance. Data from families in which this occurs give a ratio of 320 affected to 302 normal. A man with this disease suffering from bleeding of the stomach was thought to have gastric ulcers. During the course of the examination, it was discovered that the man's father had suffered from frequent nosebleeds all his life. This information helped the doctor make the correct diagnosis and to administer the proper corrective measures, which consisted in cutting out the large ruptured blood vessel.
You seem to be bringing all kinds of ratios up, Emerson. Just how significant are they?
Well, ratios of that sort constitute the best evidence we have that the trait in question is inherited as a dominant one. Some such characteristics have had their origins hundreds or even thousands of years ago.
Thousands of years ago? Must be some tough trait.
But they do extend over a period as long as that, Bob. For example, there is a dominant condition in which some of the joints of the fingers are stiffened as a result of the fusion of certain bones. A family in England with this trait can trace its ancestry back to one of the characters of Shakespeare's Henry VI, a man named John Talbot, who was killed in battle in 1453 by the blow of a battle axe on the head.
Poor John. But what about this finger business?
Well, some years ago, the family had Talbot's tomb opened for repairs. The skeleton was identified by the cleft skull. Examination of the finger bone showed the same kind of fusion that is found in the living descendants. The family genealogy shows that this trait must have been handed down for more than 500 years through at least 14 generations. Now, that's a good example of a certain kind of continuity between the present and the past.
That was certainly an interesting case.
And Dr. Stouffer says that there are a good many dominant traits in man, many of which, like stiffened fingers, are comparatively harmless. Some, however, are more serious. That is the case with a type of mental disease known as Huntington's chorea.
Is this about another family, Emerson?
No, Bob. 962 cases of this condition in the United States have been traced back to half a dozen individuals who migrated to America during the 17th century. And it's an excellent example of the way a dominant trait may spread in a population.
Well, these traits we've been talking about have all been dominant traits, haven't they? Are there other kinds?
Oh, yes, Bob. A number of traits in man have been found to be inherited as recessives.
Which means?
Well, in general, they do not tend to be transmitted from generation to generation. Often they appear in families in which both parents are unaffected, and not infrequently there are no other cases in the family.
Very interesting. What sort of traits come under the heading of recessives?
Well, albinism is inherited in this way. Practically all albinos have normally pigmented parents. When data is collected from large families in which there is at least one albino, a ratio of 3 normal to 1 albino is obtained.
Just like Mendel's peas.
Exactly, Bob. Then a number of rather rare human diseases are inherited as recessives. One of these involves the development of blisters on the body as a result of slight friction.
How about diabetes, Emerson? Seems I've heard that can be inherited.
Dr. Stouffer says that there is now evidence that diabetes, susceptibility to diphtheria, and to infantile paralysis are recessives, Bob. Inability to taste the bitter quality of a certain chemical substance has been proven to be inherited as a recessive trait, too. On the average, 3 out of 10 persons are unable to detect any taste to this substance. Those who can taste it may react so strongly that they spit it out as soon as it is put into their mouths. Probably a good many differences in sensory discrimination are hereditary. There's an interesting angle there, Bob. Most cases of color blindness, better termed color weakness, since a colorblind person is not without ability to distinguish colors, are the result of recessive heredity. Inheritance of this trait differs from that of ordinary recessives in that, in almost all cases, an affected male receives the trait as a result of a hereditary factor handed down to him by his mother.
Then women are more apt to be colorblind?
Oh, on the contrary, Bob. Color blindness in women is rather rare. Among Americans, about 1 out of every 100 women are affected, compared with 8 out of every 100 males. The reason for this is that colorblind females must have received a factor from both mother and father.
Seems to me I've heard of something else which is handed down from mother to son.
There are a number of instances of that kind of inheritance. It's known as sex linkage. 2 kinds of hereditary blindness are sex-linked, as is hemophilia, a disease in which the blood does not clot normally, and a form of muscular dystrophy characterized by the wasting away of the muscles.
This heredity is an interesting business, isn't it?
It certainly is. One of the most recent and brilliant achievements in the field of medicogenetics is the discovery of the Rh blood factor in man and its significance in anemia of the newborn, and in a good many cases of prenatal death.
What do you mean, Rh blood factor?
Well, by means of certain blood reactions, people may be grouped into either of 2 groups known as Rh plus and Rh minus, about 15% of the population belonging to the Rh minus. Trouble may arise when an Rh minus mother has an Rh plus child.
What kind of trouble?
In such cases, if red blood corpuscles of the embryo get into the circulatory system of the mother, and possibly through slight injury to the placenta, the body of the mother may produce antibodies to destroy them. These antibodies also get into the circulatory system of the embryo and act to destroy its red corpuscles. The Rh plus is inherited as a simple dominant over Rh minus, much the same as yellow is dominant over green color in peas. It is now possible to type persons and determine whether they may produce offspring of the incompatible group. It is probable that even if the mother is Rh minus and the child the incompatible Rh plus group, trouble may not result if certain prenatal conditions are not present.
I'm afraid that's a little over my head. How about the other types of blood? I mean the more familiar ones like A and B.
The inheritance of the blood groups O, A, B, and AB has been firmly established within the last 15 years, and there is now mounting evidence that if mother and child belong to incompatible groups, prenatal death may result from the same sort of mechanism as in the case of the Rh factor. The discovery of these serological and genetic relationships has cleared the way for a greater measure of control over several hitherto baffling human disorders.
Well, heredity seems much more of an open book than when we started out on this excursion, Emerson.
Well, if that's the case, good. Many persons regard heredity, with a sort of fear, somewhat after the manner of Oscar Wilde, who declared that heredity is the last and most terrible of the fates. What they fail to perceive is that a great many traits in which heredity is a more or less important cause may be cured or corrected. This is true of astigmatism, short-sightedness, hair lip, cleft palate, webbed fingers, diabetes, cataract, inguinal weakness resulting in hernia, pernicious anemia, and the like. For others, such as abnormal brittleness of bones, muscular atrophy, severely malformed hands and fingers, certain kinds of tumors, hereditary blindness, and deafness, and some forms of insanity, little or no control is now possible. Control of these will take the form of intelligent measures to prevent the spread of such conditions in the population. This will be an important problem in a country in which improvement of the quality of human life is one of our chief concerns.
And ladies and gentlemen, if you would like to have for your scientific library a copy of a paper by Dr. James A. Stouffer of the Biology Department at Colgate University, which contains all the facts we brought you here in more details besides, all you have to do is address your requests to Excursions in Science in care of the station to which you are now listening, asking for scientific paper number 146 entitled Human Heredity. That's Human Heredity, scientific paper number 146. And now, lo and behold, it's once again time to consider the matter of answering some scientific questions. The questions have been submitted by you listeners. The answers are as accurate and up to the minute as can be obtained, since they are based on information supplied by staff members of the General Electric Research Laboratory or other equally reliable sources of scientific fact. But let's get on to the questions, and here's the first one, Emerson. Our friend writes that he's heard if a regular pack of playing cards were divided into 2 equal parts, one containing 25 red and 1 black, and the other containing the balance of the deck, that the chance of drawing a red card was no better from one pack than from the other. He wonders if this is true. The reason which was given him was that any single event is not predictable or something of this nature.
Well, the chance of drawing one red card from the part of the deck containing only one red card is 1 to 26.
Well, then, Emerson, how about drawing the red card from the other pack, the one containing the balance of the pack?
Here, the chances are 25 out of 26, you see.
Well, I suppose the more this operation is performed, the more chances there are of getting it?
Well, no, contrary to what you'd think, perhaps. If the operation were performed, say, 1,000 times, you'd still come close to getting it only one time out of 26.
Well, now our listener would also like to know what the chances are of a tossed coin falling 50-50 heads and tails in the case of multiple tossing. Would the deductions, if any, be more reliable after, say, 10,000 tries than after 6 or 8?
Here the reliability increases with the square root of the number of trials. This is true of any such game of chance. The 6 or 8 trials which our listener mentions wouldn't be sufficient, therefore, to give a dependable average. The theory of probability arose from studies of cards and dice games. Thus, if only for historical reasons, we can still regard these games as making valuable contributions to science.
Along with contributions to the linings of certain people's pockets.
Perhaps.
Ah, well, along to our next inquiry, which is viz., i.e., and to wit, is the use of aluminum cooking utensils injurious to health?
The answer is no. Investigations of this matter have been made time and again by competent medical and technical authorities. No evidence that the use of aluminum cooking utensils is harmful has ever been obtained. As a matter of fact, a good many of our common foods and a great deal of our drinking water contain small amounts of aluminum compounds. Baking powder and eggs contain some aluminum. Potatoes and apples and carrots and milk contain aluminum. There is no evidence that aluminum ware used in cooking is injurious to health.
Now, a 7th grade science class would like to know which gives off the greatest amount of heat, hard or soft wood. Well, Emerson, which does?
Well, per unit weight, the heat would be the same from the hard and the soft wood. But for a given log, the hard wood would give more heat. The composition of both the hard and the soft wood is essentially the same, but the hard wood has a greater density, of course.
And the gentleman in the control room will be accusing us of greater than usual density if I don't hasten to say thank you, Emerson Markham, and goodbye, everyone, until our next excursion in science.